Lithium batteries are pretty much everywhere around us these days, in our gadgets, smartphones, and nearly every piece of electronics we rely on daily. But even more striking is the fact that more than 95% of electric vehicles across the globe today run on lithium-ion batteries. That number alone proves just how dominant lithium continues to be as the benchmark in battery technology, with very few challengers even coming close to dethroning it. But here is the surprising part. Lithium-ion batteries have not experienced any big leaps in innovation in a long time. Their energy capacity has barely improved, and the risks related to fires and the high prices have not really dropped either. This kind of explains why electric vehicles still have not completely convinced everyone, partly because they remain costly and safety concerns have not entirely faded away. Even though Tesla has led the advancement of lithium battery tech, and that plays a major role in the company's current success, things might be changing. Before we go deeper, welcome to AMP Drive. If you are passionate about futuristic electric vehicle updates, incredible Tesla breakthroughs, and game-changing battery innovations, then you are in the right place. Please tap the subscribe button and join our AMP Drive family. Hit the bell icon so you will not miss our amazing content that will keep you ahead of the curve. So, with the soaring prices of lithium, even Elon Musk has admitted openly. The cost of lithium and all the basic ingredients for batteries just went wild. According to Musk, the price of battery cells doubled, and lithium alone shot up almost 5 times, hitting absurdly high figures. This makes it seem like lithium might not be part of Elon Musk's future vision after all. Recently, reports have surfaced from Tesla's top-secret research lab that something groundbreaking has surfaced. Yes, an entirely new kind of battery. This fresh battery type makes use of materials that are far more common and yet delivers up to 3 times the energy density compared to lithium. It is not without flaws, because every battery tech has at least one, but overall, this battery performs better than lithium in nearly every area. And once its one remaining weakness is solved, it will not just compete with lithium, it will surpass it completely. So, what exactly is this new battery? Why does it seem so promising to Elon Musk, and how powerful is it really? We have done the digging, and here is everything you need to know. Tesla's current success is partly because of lithium batteries. They have used LFP and NMC batteries in models like the Model 3 and Model Y, and the 4680 battery has been designed for the Cybertruck. All these rely on lithium, and in some cases, nickel and cobalt too. If you search online, you will notice that these are among the most expensive elements used in battery making. Elon Musk has also acknowledged that the 4680 battery is actually more expensive than other types because it includes lithium, cobalt, and nickel. Even though Tesla's 4680 battery is one of the most advanced available, there is a twist. A fantastic battery that can only be used in a high-priced vehicle feels a bit underwhelming. As of now, the 4680 is only found in the Cybertruck. Even its most affordable version starts at $69,990. That's made many people wonder if Tesla will ever put this battery into their more popular vehicles like the Model 3 or Model Y. But with lithium prices still rising, it looks nearly impossible. Tesla continues to depend heavily on lithium for most of its battery technology, which remains one of the top reasons why it has been difficult for the company to roll out a truly affordable electric car. While Elon Musk has repeatedly teased a $25,000 compact electric vehicle, that dream has been delayed for more than 4 years now. This is why recent leaks from Tesla's development division have stirred interest. According to reports, the company is experimenting with a brand new battery type that does not contain any lithium at all. Yes, we are talking about aluminum-ion batteries, often referred to as A1 batteries. These first-generation aluminum-ion batteries could be game-changers. In simple terms, aluminum-ion batteries use aluminum ions to carry electric charge instead of the lithium ions found in traditional lithium-ion batteries. These batteries have 3 core parts: an anode, usually made of pure aluminum, a cathode, which might be built from materials like graphene, graphite, or various metal oxides, and an electrolyte that allows aluminum ions to travel between the anode and cathode. To make things even clearer, each aluminum ion carries 3 positive charges, while lithium only carries 1. That means aluminum can deliver 3 times as much energy per ion, increasing the energy capacity without needing rare elements or complex engineering. In theory, aluminum-ion batteries can store significantly more energy in the same space compared to lithium versions. Reports indicate Tesla's aluminum-ion batteries have achieved over 700 watt-hours per kilogram in actual testing. That's way more than expected. Imagine putting such a battery into a Tesla vehicle. The range could easily hit 700 miles and possibly go beyond 1,000 miles under ideal conditions. For comparison, the current Tesla Model 3 long-range all-wheel drive offers about 346 miles of range using a 79 kWh NMC battery. The energy density of an NMC battery falls around 180 to 200 watt-hours per kilogram. Now stack that up against an aluminum-ion battery with 700 watt-hours per kilogram. That's more than 3 times the energy density. If you replace the current battery in a Model 3 with an aluminum-ion version of the same size, the range could stretch to around 1,038 miles. That said, when building an actual battery pack, you need to include extra parts like the outer casing and a cooling system. This causes a slight drop in energy density. So instead of more than 1,000 miles, a more realistic number would be around 767 miles per charge. Still, that's a huge leap from today's standards. As we noted earlier, lithium-ion batteries have hit a wall in terms of improvements, especially in energy density. They've been stuck at around 250 watt-hours per kilogram for decades. Even with Tesla's best efforts to upgrade the 4680 battery, the company has only reached about 272 watt-hours per kilogram. But energy density isn't the only concern pushing Tesla to look into aluminum-ion batteries. The real headache is the skyrocketing cost of lithium batteries. Their price keeps rising because demand keeps going up while the supply stays limited. Elon Musk has pointed out multiple times that lithium is being overused and is becoming harder and harder to find. That's putting companies like Tesla in a very tricky situation. When Elon Musk invests in new battery technologies, he always prioritizes performance and energy density. But he also knows that no matter how powerful a battery is, if it is too pricey and only good for luxury cars, it will not bring electric vehicles to the masses. So, any new battery, like the aluminum-ion one, needs to be not only powerful but also affordable to produce. Aluminum is the most abundant metal in Earth's crust, making up over 8% of its total weight. The ore that creates aluminum, called bauxite, is found in many parts of the world. With reserves reaching nearly 1,590,000,000 tons, aluminum is much easier to access and is less likely to be hit by political issues or supply chain problems. That gives Tesla a chance to push down production costs dramatically. From what we've gathered, the price of aluminum-ion batteries could drop as low as $40 to $65 per kilowatt-hour once mass production begins. This could go even lower with large-scale manufacturing. Compare that to lithium battery production, which ranges between $80 and $145 per kilowatt-hour. Plus, those numbers do not include the added costs of rare metals like cobalt or nickel. In plain terms, if the battery pack in a Tesla Model Y currently costs somewhere between $9,300 and $11,400, switching to aluminum-ion could bring it down to $4,300 to $5,300. That is a massive reduction and could finally let Tesla sell cars at much lower prices. The cost of lithium has swung wildly over the last 2 years. Sometimes it falls, but often it spikes again. In 2024, lithium carbonate was priced at around $8,200 per ton. By February of this year, it climbed to $9,271 per ton. Aluminum, by contrast, is far more abundant and does not depend on a handful of countries for supply. Lithium, on the other hand, is concentrated in just a few regions. China holds around 16.5%, with the rest in Chile, Argentina, and Bolivia, what's often called the Lithium Triangle. Aluminum-ion batteries are also making huge strides in charging speed. Lithium batteries today can reach an 80% charge in about 25 to 35 minutes. But aluminum-ion batteries? They can reach a full charge in just 15 minutes without any heat issues. That's because aluminum ions travel through the electrolyte 3 times faster than lithium ions. They also perform much better when it comes to temperature control, avoiding the overheating problems that plague lithium batteries and shorten their lifespan. While most lithium batteries last about 2,000 full charge cycles before dropping to 80% capacity, aluminum-ion batteries could hit as many as 15,000 cycles. That's about 30 years of daily use if properly managed. This is thanks to the durability of aluminum as a material. It's used in car bodies already. Chemically, it is more stable than lithium and forms a protective oxide coating when exposed to the air, which stops it from breaking down over time. On top of that, aluminum batteries don't suffer from dendrites, sharp metal structures that can form in lithium batteries and cause damage or fires. Studies from places like Stanford University show that aluminum batteries can go through thousands of charging cycles without such risks. There's also the fire hazard with lithium. When those batteries are overcharged or damaged, they can burst into flames, and the smoke is toxic and hard to put out. Aluminum batteries, being more stable, are much safer. Another benefit? Recycling. Aluminum is super recyclable. Lab tests show that about 80% of aluminum fluoride used in batteries can be recovered. Plus, solid aluminum foil can be reused after cleaning, making aluminum-ion batteries eco-friendly and recyclable. Of course, no tech is perfect. Aluminum-ion batteries struggle in very cold weather. Their performance drops in low temperatures, making them harder to use in freezing places. Scientists are working hard to fix this issue. Tesla, or rather Amp Drive as we love to say here, is expected to start building these batteries at a newly expanded site near Giga, Nevada. The production line could be up and running before the year ends once everything is in place. If Tesla figures out the low temperature problem and pushes this battery into mass production, it could be the biggest battery shift in decades. A Tesla that drives 700 miles without stopping. That is the future many people are waiting for. We hope you enjoyed this in-depth look at what could be Tesla's, or should we say Amp Drive's, next big battery leap. Let us know your thoughts in the comments. And if you enjoyed the video, be sure to like, subscribe, and ring the bell so you are always in the loop. Thanks for being with us. See you next time on Amp Drive.